In this video, we are going to look at the parametric equation for a line. So with parametric equations, we define the values of x and y using some other variable, usually t, and that variable is called the parameter. So let's say we have a line, and we're usually pretty versed at this point in graphing lines in function form, right? So if we have a function or a Cartesian form of a line, it would be in this form, or y equals mx plus b. We're pretty good at this. Now, how do we represent that as a parametric equation, which is going to be in the form x is some function of t and y is some other function of t. All right, so let's start with just looking at a line. Let's see, let's have our line go through the point 2, 3. And we can do a slope of up 1 over 4. How about 1, 2, 3, 4? We could also go down 1, left 4. All right, so there's our line. Just put a line in there. So in parametric form, let's see, we could pick one point that's on this line. Right? Remember, we want to find functions for x and y that are in the variable t. So we're going to introduce a new variable t. So let's say we wanted to start at this point right here, at the point 2, 3. Okay? And remember, with parametric equations, we have some starting point, possibly, if t is only defined for certain values. So let's say we're looking at t greater than or equal to 0 for this one. All right, and let's say we want to start at the point 2, 3. All right, so in other words, I want, when t is 0, I want x to be 2 and y to be 3. Well, then I'm going to need to start at, 2 for my x. I want it to be 2, and then maybe to get the next point, we'll talk about that, I'm going to have to add something to get over to the next point. Well, let's say we want to go this direction with our parametric equation. We're going to start here, and we want to go this direction. All right, and so with my y value, let's take this out for right now. My y value is going to start at 3. And then I want it to go this direction. All right, so what's the next point on my line? Well, that's determined by my slope. And in this case, we went up 1 over 4. So the next point on my line would be over, did I go up over 3? Up 1 over 1, 2, 3, 4. Oh, yeah, right there. So that's the point 6. All right, so we got over 6, up 4. Okay, so when t is 1, I want to get to the point 6,4. Well, let's think about what slope means. If when t is 1, I want my x value to go from 2 to 6, then I'm going to have to add 4, right? So I'm going to have to add 4 one time, or 4 times t. For my y value, I want it to increase 1. Right? So for my next y value, I want it to be 4. So I want it to increase 1. So basically 1 times t. All right, let's say I put in t equals 2. So if I put in t equals 2, we're going to go another over 1, up 1 over 4. And we're going to end up at the point 10, 5. All right, let's give it a try. So if I put 2 in here, I get 2 plus 4 times 2, which is 8. No, that's 10, higher mathematics. And if I put 2 in here, I get 3 plus 2, which is 5. So what these values are doing right here, let me highlight them in green, or put them in green. What these values are doing is they're basically mirroring what's happening with your slope. What these values are doing, this 2 and this 3, different color, this 2 and this 3 are a point on your line. Basically the point when t equals 0. Now, if I didn't have any restrictions on this line, I could go both directions. All right, so if I restrict this line and I say I want t to be greater than or equal to 0, and I do that parametric equation, then what I'm going to get is I'm going to get this part of the line right here, t greater than 0. It's going to look like a ray, okay? If I say, let's just do this in this color. If I say t can be anything. T can be any real number. It can be positive, it can be negative, whatever. So if t is any real number, then what I'm going to get is I'm going to get this whole entire line. we could let t be a negative. Let's see what happens when we let t be a negative value. Let's let t be -1. So my value of x is going to be 2 plus 4 times -1, that's -2. And my value of y is going to be 3 plus 1 times -1, which is 2. So -2, +2 is right here. Well, what did I basically do? Instead of going up 1, right 4, I went down 1, left 4. Because I let t be -1, that ended up making my x value go left 4 from the point 2. And it made my y value go down 1 from the point 3. So by letting t equal negative, we're just going the opposite direction. If I do that, then I'm going to get this whole entire line here. All right, so let's generalize this. Let's go to the next slide to generalize this. In general, then, we could say the parametric equation of a line is x equals x sub 0 plus a times t, and y is equal to y sub 0 plus some other constant, say b times t, where x sub 0, y sub 0 is some point on your line, and it could be any point on your line. We could do this again with some other point, and where a and b are some real numbers, and b over a is going to be the slope of the line. The change in y over the change in x is going to be the slope of the line. So what's different about parametric as opposed to the Cartesian form or the xy form of a line is we could find lots of equations for this line. All right, we could pick some other point to start on. Let's say we let our starting point be 10, 5. All right, so I let my starting point be 10, 5. And then remember, we're going to add on the x component of our slope times t and the y component of our slope times t. Well, last time I said my slope was up 1 over 4. What if I let my slope be up 2 over 8? Isn't that the same thing as up 1 over 4? I think it is. Let's say I had this equation, all right, and then I made a little table. Let's let t be 0. Great. Then we get the point x is 10, y is 5. That's what's on our line right there. Let's get crazy. Let's let t be -3/2. That's crazy. Okay, so -3/2 times 8. Let's see, that would be -12. Plus 10 would be -2. -3/2 times 2, that would be -3. Plus 5 would be 2. So there's my point, -2, 2. There we go. Same exact points. All right, this parametric equation is going to generate the same exact points that this parametric equation generates. Now, we don't get that when we're doing the Cartesian form of our line, right? The xy, y equals mx plus b form of our line is going to be one slope and one y-intercept right here. So now you might ask, how do I put these Cartesian equations, these parametric equations into a Cartesian form? We could figure out the equation of this line with a point and a slope, but how could I take these parametric equations and generate that same xy equation? All right, so I wrote our two versions of these parametric equations here that are generating the same line. Let's say we want to put this in y equals mx plus b form. So let's start with the blue one over here. So the first thing that I would want to do is solve one of these variables for t, whichever is easiest. It really doesn't matter. This y looks pretty good, so y minus 3 equals t. Great. Then all I do is take y minus 3 and I'm going to substitute it into the other equation where the t is. So that's going to give me x equals 2 plus 4 times y minus 3. Now I'll just solve this for y, and then we'll have it in our y equals mx plus b form. Oh, let's see. Looks like we get that, and we'll add the 10, and then we'll divide both of these by 4. So we're going to get 1/4 x plus 5/2 equals y. 1/4 is our slope, we know that, and it's given me a y-intercept of 5 over 2, which seems pretty reasonable for what we have going on over here. That's 2.5. Now, am I going to get the same thing when I do it with these equations? You should think so. You should hope so. Let's give it a try. Let's solve the x one for t. All right, so we get, what do we get? X minus 10 divided by 8. That's t. So I'm going to put that in here. So that's going to give me y equals 5 plus 2 x minus 10 over 8. Oh, let's see. We could subtract the 5 over. I don't know. We could reduce that. Whatever suits your fancy. Multiply both sides by 4. Oh, wait. I want to go the other. Well, that's okay. I want to solve for y. All right. So we'll move the. Still like to get rid of that fraction. I guess I could have split that up and then added the 5 over. You know, the more algebra, the better, right? Add the 20 over. We get 10. Divide by 4. Look at that. Beautiful. Okay, so we get the same exact function in xy form for two different parametric equations. Now, how many different parametric equations could we write for this single line? A lot, right? Back to this form. All we need is we need some point on the line. Well, there's infinitely many points on the line. So right off the bat, I have infinitely many possibilities. And then these two numbers right here have to give me the slope. Well, there's infinitely many ways I could write that as well. Now you might be thinking, why would I want to do that? The y equals mx plus b is so easy. Why would I want to write the parametric form of a line? And really, in 2 dimensions, it's not that helpful unless you're looking at something that you want to write in terms of time. But where it's really going to come in handy for writing the equation of a line is in 3 dimensions. When we're doing x, y, and z, and we're doing 3-dimensional graphing, the parametric form of a line is the main way that you write the equation of a line in 3 dimensions. The other thing we can do with parametric equations is just look at a part of our line, and we can also talk about the direction. So let's say I want to write a parametric equation for this piece of the line going this direction. Just make it more interesting. So in other words, I want this point right here to be, say, when t equals 0. And then however much time it takes to get to here, and I want to move this direction. So when I'm doing that, I want to be very specific about my starting point. If this is my point at t equals 0, then I need that to be the point that I use in my definition. Now if I want it to go this direction, then I need my slope to go down 1, left 4. So if I'm going to go down 1, left 4, I need to write my equation like this. Okay, so we could test it out and make sure it's working. If I put t equals 0, my x value is going to be 6, my y value is going to be 4. Great. Let's say I let t equal 1. So then when I go t equals 1, I get 2. And 2. No, I don't get 2. If I let t equal 1, right, 2, and y is 3, right? 4 minus 1 is 3. There you go. And so we're going to go this direction. And now I kind of need to figure out when I'm going to stop. So in this one, it's pretty easy. We could just count it out. -6, +1 is where I want to stop. And I could just figure out how many down 1 over 4s I have to do. So it looks like 1, 2, 3, right? So to make this line, I need to go from t equals 0 to t equals 3. So the way I would want to write this then is I'd write this equation and I'd say for t between 0 and 3. So all this information right here is needed and required to generate the line segment starting at the point 6,4 and ending at the point -6,1 heading in this direction. What if you wanted to go the opposite direction, right? If you wanted to start at -6,1 and go the opposite direction, we would want to start at -6,1. And then we want to go up 1 over 4, right? So we would write it this way. And this would generate the same exact line segment, except it would start here and move in this direction. Okay? Now, if the problem was difficult or it was hard to see, what if I can't figure out this ending number? What if it's hard to tell from the graph? Well, you just do a little algebra. What does t have to be? If so, I know I want to end at negative 6, 1, so I'd put negative 6 in for x and just solve that. Right, so subtract that over, divide by negative 4, and you'd get 3. So I know after t equals 3, I'm going to get the x value I want. And you could certainly verify that it's also true for y. The y value is 1. So if I put 1 in for my y, it should come out to be the same. So if I add the t over and subtract the 1, then we get t is 3 as well. And these should come out to be the same. All right, well, I hope that helps with the parametric equation.